lesson is writing half equations. You should have hopefully finished your do now, and I'm just going to go to the first slide, and we're just going to remind ourselves about displacement. We looked at this last lesson, and we can see in this displacement reaction we have magnesium reacting with copper sulfate to produce magnesium sulfate and copper. What can we see has happened here? We can see that the magnesium has displaced the copper in the copper sulfate to become magnesium sulfate. We also looked at last lesson how to write ionic equations and what ionic equations show. Here again we're still looking at the magnesium reacting with the copper. You can already see that we no longer have our sulfate ion. If you remember, we get rid of those spectator ions. And what do these ionic equations actually show us? Here, for example, we can see that the magnesium atom loses 2 electrons to become a positively charged ion or positively charged ions. And we know that this loss of electrons is always called oxidation. Oxidation is the loss of electrons. And then if we look at our copper ions gain 2 electrons to become neutral atoms, and this gain of electrons is called reduction. So we've gone from a copper ion to a copper atom, okay? And we've gone from a magnesium atom, to a magnesium ion. The magnesium ion lost 2 electrons, and the magnesium atom lost 2 electrons, and the copper ion gained 2 electrons. So remember, the gain of electrons is called reduction. Reduction is the gain of electrons. Oxidation is the loss of electrons. So a redox reaction is one in which oxidation and reduction take place at the same time. And so we can see both of those have taken place here in this reaction. What is a half equation, or what does a half equation tell us? So a half equation is used to represent the reaction that happens at an electrode during electrolysis. So remember, our cathode and our anode. It shows what happens when ions gain or lose electrons. In half equations, electrons are shown as E with our negative charge. Okay, so this is just showing us our electron. Half equations include electrons, whereas ionic equations do not. An ionic equation is split into half equations. So it's actually the ionic equation, if I just go back here, it's actually the ionic equation, sorry, from the page before, that becomes our half equation. Okay? Again, so we're still looking at half equations. So what does the half equation tell us? And we're still looking at our magnesium, and it reacts with our copper. So here we can see magnesium atoms lose 2 electrons to become positively charged ions. So the magnesium atom had to lose 2 electrons to become this ion. Okay, so remember, we already know that the loss of electrons is oxidation. But what happens is that in this half equation, we are also showing those electrons. Okay, let's look at the copper. So we're looking at half equations. Remember, shortly we're going to see where these take place, so at which electrode. We're looking at copper. A copper ion has had to gain 2 electrons to become this neutral atom. Okay, so here we're showing the gain of those electrons. Remember, this signifies as our electrons. It's gained 2 electrons. Right, so the gain, remember, of electrons is called reduction. Let's still work with our magnesium and copper reaction. So here we've got the ionic equation. So basically think of half equations as 2 halves of an ionic equation. Okay, 2 halves of an ionic equation. So all we're simply doing is splitting it up. So each half equation is basically going to focus on one kind of element. So for example, here we have magnesium and copper. Okay, so I'll say that again. Basically, just think of your half equation as 2 ionic equations, so 2 halves of ionic equation, and we're just splitting it up. Okay, so each of those half equations focus on one element in that equation. Yeah, and what we're going to do, we're going to use these steps to help us as well. So first, let's choose the element that we want to work with. We might as well start with magnesium. So we're going to look at magnesium. And you can take this down in your books as well. I'm going to practice first of all with this. Right, so it says pick one element that's on both sides of the equation. I've picked magnesium, and then it says write down the reactant to the product, okay? Copying from the equation exactly. So I'm just going to go from this to this. So what I should have, so we've done step 1, let's go step 2, is magnesium becoming, because remember all I'm doing is following the steps, magnesium, it's got the charge, and it is aqueous. Right, step 3 then says balance the atoms and the ions. Okay, so we're going to balance the atoms and the ions. So we know we've got one magnesium atom here. Let's put our state. We've got one magnesium atom here, and it's going to become this ion. And to balance that charge, we only need one ion. So we've got one ion. Okay, and it's aqueous. Right, step 4 then says add up the charges on both sides. Okay, so here we can see we've got magnesium atom, magnesium ion. We know an atom is always going to have a neutral charge, so the charge will always be 0. And we know that the charge on this magnesium ion is +2, so it's positively charged. Right. Step 5 says balance the charges with negative electrons. Okay, so here again you can see we have a magnesium becoming a magnesium ion, and for us to be able to get that balanced charge, so remember we want it to be able to cancel each other out, we're going to need to add 2 negative electrons. So remember these 2 negative electrons plus these 2 negative electrons should balance each other out and make the charge 0 here, and also make the charge 0 here. Okay, so here is our half equation. Right, let's try that again. Let's do it with copper this time. So again, I'm going to follow step 1. I've picked my element, which is copper, and now I need to write down the reactant to the product, copying from the equation. So I'm copying from this ionic equation. So from the reactant to the product, I had my copper ion, so I've got that positive charge becoming the copper neutral atom. Okay, step 3, I need to balance the atoms and the ions. Okay, so I've got my copper ion, I've got one copper ion here, and it's produced my copper atom, and I've got one atom here as well. Right, and again now step 4, we need to add up the charges on both sides. So again, my copper ion has a charge of +2, so we can see it's positively charged, and my copper atom has no charge, because remember atom is neutral, so it should be 0. So here we can see both of these charges have not cancelled each other out, so we now need to balance the charges again with our negative electrons. So again, I'm going to put my copper to +2 charge. Now if I want this to become that atom, what does it need to do? It needs to gain those 2 electrons, those 2 negative electrons, to then become that atom. Sorry, that should be there, to then become that atom. So now we can see this has cancelled out this, so it should have a charge of 0, and we already know our atom has a charge of 0. So let's do some more practice. If you go to this next page of your worksheet, it says the ionic equation for a reaction is as follows. use this ionic equation to write two half equations. So you can already see that the steps have been done for you. They identified all of the ions present in this reaction. They found the spectator ion that was present on both sides. They've deleted that spectator ion in the products and deleted it in the reactants, and they're now left with the ionic equation. We now need to write the two half equations. Okay, so let's start off with our first element. Again, we're just following the steps, and the first element we're going to look at is Fe, which we know is iron. Okay, so step one, we're going to look at iron. Iron is Fe. Right. Remember, we're going to write, we're just using ionic equation. Okay, so we're going to write down the reactant to the product straight from the ionic equation. So here, step two, what we should have is iron, which is in its solid state here. So iron as an atom becoming iron, an ion. Okay, with that +2 charge. Right. We then need to balance the atoms and the ions. Okay, so we should have Fe. So we've got one atom here, and we've got one ion here. One ion here. With our +2 charge, I mean that's aqueous. Right, step 4 says add up the charges on both sides. Okay, so here we can see again, and it might seem tedious rewriting it, but breaking it down like this should be helpful. So we've got a charge, which is 0, because remember it's our atom. And then if we look at our ion, we know here that we've got a charge of +2. Okay, and it is aqueous. Right, now we're doing our final step, which is to balance the charges with electrons. So remember, those half equations are showing those electrons. So here again, we've got our iron atom producing our ion. We already know the atom has a charge of 0. For us to be able to cancel this out and balance it, then we're going to need 2 negative electrons. Okay, so now that then becomes 0. We now have that charge of 0. That is balanced. Let's try it again with copper. That's our second bit here. So 1 copper. Step 2, we're going from this to this. So our copper ion becoming our atom. We want to make sure we've got the same number of atoms and ions. So C2 plus, you know, is 1 ion. Oh, now I'm getting confused. 1 ion and 1 atom. Step 4, we're going to balance the charges on that ion on both sides. So we're going to add up the charges. So we know we've got +2 charge here, and here we don't have a charge because it's a neutral atom, so the charge is 0. And then finally, step 5, we're going to balance those charges. So the copper ion, for that to get a charge of 0, needs 2 electrons. Yep, to become that copper atom, which should mean now that both sides have a charge of 0. Right, so let's try this next one. This is a redo. It says in your exercise book, so I'm just going to do it on a piece of paper, the ionic equation for a reaction is as follows. Okay, so they've done the full equation, they've then written the ionic equation by getting rid of the spectator ions, and now you have to write the 2 half equations. So we're going to do the same thing, and we're going to follow our steps. So I'll just rewrite this out just so that we can see. So we've got bromine, so Br2 plus 2, so we've got iodine producing 2Br aqueous and iodine, which is solid. Right, so same thing, we're still just going to follow our steps. The first step, remember, we're going to pick one element from each side. So let's start with our bromine. And we're going to write down the reactant to the product straight from here. So from bromine, Br2 to our bromide ion, which is 2Br. Right, then we're going to balance the atoms and the ions. So we can see here Br2, which means we have 2 atoms and then 2Br with our negative charge, which means we have 2 ions. So we've got 2 atoms and we've got 2 ions. Come back later. Yeah, we've got 2 atoms and we've got 2 ions. Sorry about that. So I'm just not right. So step 4, we need to add up the charges on both sides. Okay, so we've got our bromine atom, and again we know our atoms are always going to be neutral, therefore the charge will be 0. And our bromine ion, or bromide ion, Br2 with our negative charge, you can see it has a charge of -2. Right, so we now need to be able to balance the charges with electrons. Okay, so if we sorry about that, guys. All right, so if you look at step 5 now, it says balance the charges with electrons. So again, I'm going to write out the half equation to my right. Sorry, let me just start that again. Just got blown off. Right, so we've got my Br2, and this atom needs to become an ion. Okay, so for this atom to become an ion, so remember we already know it had a charge of 0, but we want it to have the same charge so we can cancel each other out. It had a charge of 0 there, but it needs to have the same charge so it can cancel each other out. It's going to need 2 electrons like so for us to be able to go over to our bromide ion, which means we've got a charge here now of -2, which allowed it to become this bromide ion with the same charge of -2. So we balance the charges with electrons. Right, let's look at our iodine. Again, we'll just follow the same step. Iodine, we're going to write down the reactant to the product, simply just going to copy it from the ionic equation. So we can see we had 2 iodine, our ion has a negative charge to produce our atom, and remember iodine is one of our atoms that exist diatomically, and I've got our state there. Right, step 3, we need to balance the atoms and the ions. So we've got 2 iodine ions, so here we can say we have 2 ions, and we have 2 iodine atoms. Remember, it's a diatomic, okay, so that's why in this instance it's 2. So we've got 2 atoms here. Right, step 4, we now need to add up the charges on both sides. Okay, so again, just going to write our ion for iodine, making our iodine atom, and here we can see the charge. Now because we've got 2 here, 2 iodine ions, we've got a charge of -2. Okay, so -2. And then here again we know our atom is going to have a neutral charge, which is going to be 0. And then finally, step 5, we need to balance the charges with the electrons. Okay, so here again we've got 2 iodine, our iodine ion. We know this has a charge of -2. Okay, and this, we need to make this charge a -2 as well. So all we need to do here is add our 2 electrons, which should now mean that we've balanced the charge with 2 electrons here as well to make it -2. Okay, you need to now attempt the you-do in your exercise book. Just take your time. Remember, all you're doing is basically splitting the ionic equation into 2 half equations. That's what we mean by half equations, okay? So you'll work with one element and then you'll work with the other element. Just follow each step and just keep practicing, and you'll be fine.